because we have come across different types of work. Normally we hear about hard work. Every parent says to his child, please do hard work. Then mental work, then physical work, so many different types of works, smart work. But in physics, the term work has got a different meaning. And in physics, work is said to be done only when, so we denote work by the term W, and in physics, work is said to be done only when there is a force acting on a body. There should be a force which must be acting on a body, and there should be displacement for the body in the direction of force, or at least in the direction of component of the force, in the direction of force or in the direction of component or resultant of force. I will just explain what it is, but let me say these are the terms: resultant of the force. Now, so two components are needed. One force is needed, one displacement must be there. For example, we normally say a person who is pushing a wall from morning to evening does no work. Even though he has lost almost all of his energy, he didn't do any work. Because see, even though he has applied force, the body didn't get any displacement. The wall remained there it is. So force should be there and displacement should happen. So displacement we denote by the letter S. Now force can be applied in different ways, and also displacement can happen in different ways. For example, assume a body kept horizontally and you are applying a force horizontally. The body is getting displaced by a distance S. So work done in this case is applied force multiplied by the displacement. Verified. Now assume you are applying the same force at an angle. This is your body. You are applying a force. You are sometimes pulling it like this. You are applying a force like this. Now the force is making an angle of theta with the horizontal, and the body is getting displaced along the horizontal. So this is what the displacement is. Now in this case, how will you find the work done? So as I said in the definition, work is said to be done when you have a force being applied and displacement occurs in the direction of the force. Now in this particular case, what you have to do is you have to take the component of the force. In this case, the force is in that direction and displacement occurring like this. So what I should do is I should resolve this force into two components, horizontal component and the vertical component. Now horizontal component is taken as F cos theta and vertical component is taken as F sin theta. So you may ask me why F cos theta and F sin theta. Now just see, this is our force, this is the theta which it makes. So horizontal component means I just draw a line perpendicular to the horizontal axis, x axis, and where it meets gives me the magnitude of the horizontal component. So this is F horizontal component, let it be FH. Now how to find this much? As per trigonometry, this is adjacent side. If this is the angle, this is adjacent side, and this is the hypotenuse. So adjacent side by hypotenuse gives you the cos theta. So what I need is adjacent side. So it will be equal to hypotenuse times cos theta, and my hypotenuse is F. So it will be equal to F cos theta. Similarly, my vertical component, if I extend that to the y-axis, this is my vertical component's magnitude. How to find this? So this is same as the opposite side for this angle, this much. So opposite side by hypotenuse gives me the sin theta. So opposite side will be equal to hypotenuse times sin theta, and my hypotenuse is F. So if it will be equal to F sin theta. That is why I wrote it like this: horizontal component F cos theta and the vertical component F sin theta. Hope you understood the logic. Now how to find the work done in this particular case? So work done in this particular case is equal to force into displacement, and displacement should happen in the direction of the force. Now either you should take the displacements component in the direction, but displacement is happening horizontally. So what I should do is I should take the direction component of the force in the direction of displacement. So F cos theta is what is causing it, the displacement in the horizontal direction multiplied by the displacement which has happened. So the work done in this case is force, the component of the force which has caused the displacement in the horizontal direction, that is F cos theta multiplied by displacement, gives you the work done. So you can write it as W equals F S cos theta. Now take another case. You have a body being kept on an incline. The incline is making an angle theta. So this is my body, and I am applying a force it in this particular horizontally. I am applying a force, and the body is getting displaced on the incline like this. So from this point onwards to this point, this is the displacement which is happening along the incline. This is my S. Now in this particular case, what I should do is, to find the work, I should take the component of S, because S is happening on an incline. So as we resolved for F in the earlier case, let us resolve for S in that case, in this case. So this is my S, and component of S along the horizontal will be equal to, this will be equal to S cos theta, and this will be equal to S sin theta. Now force and component of the displacement along the direction of the force. So it will be equal to F into S cos theta. Now this is my product symbol and not the vector symbol like cross product or scalar product. This is simply F into S cos theta. So we have got three equations. First one, when the force, and let me draw that figure one more time. The body is here. You are applying a force horizontally. Displacement is happening horizontally. So say directly multiply the magnitude of force with the displacement, that is F into S. Now you have a body. You are applying a force at an angle to the horizontal. You resolve its component and the displacement is happening along the horizontal. Then you take the component of F along the horizontal, that is F cos theta. Then work done will be equal to F into S into cos theta. Now the body is moving along an incline upwards. You are applying force horizontally and displacement is happening along the incline. So you take the component of the displacement along the incline, that will be S cos theta. So you will have, so this equation can be written as S into F cos theta for this figure, and for this figure work done is equal to F into S cos theta. Whether you write it like this or whether it would write it like this, the logic is same, but in this case I took the component of force along the direction of the displacement. In this case I took the component of the displacement along the direction of the applied force. So generally you can use the formula W equals Fs cos theta, and this theta can be the angle with the force and displacement makes with each other. For example, if you take this formula, now if the force and displacement are in the same direction, so what is the angle between them? Theta is equal to 0 degree. And what is cos 0? Cos 0 will be equal to 1. So W equals Fs into 1. So which formula you will get? You will get this formula. Now if the body is at an incline, then you can use this formula to find out what is the displacement along the incline. For example, Take the case of the person who was pushing the wall. In that case, I said the work done is zero. Why did I say the work done is zero as per the physicist? Here is the wall. Which is being pushed by a person, and the wall remains there it is. So force is applied, displacement is zero. So work done in that case is zero. Now take another example of a person holding a bag on his head and walking horizontally. So a person is having a bag on his head and is walking horizontally. In this case, what is the work done by the person? C is applying a force, the bag's weight is acting downwards, that is mg, and he is applying a force upwards to hold the bag. So force is acting upwards and the bag is having a displacement along the horizontal. So force upwards, displacement along the horizontal. What is the angle which it makes? Angle is 90 degree. And when you substitute in this particular equation, W equals Fs into cos 90, cos 90 will become 0. So work done in that case is 0. That is why, as per physicists, a person carrying a bag on his head and walking horizontally doesn't do any work. Same is the case of a centripetal force, work done by a centripetal force. As we all know, centripetal force is the force which always makes the body to rotate in a to move in a circular path. So force which is acting inverse along the radius is what you mean by centripetal force. Now in that case, you have a body which is having a circular motion and it is always pulled towards the center along the radius. So along the radius is the force which is acting, and the body is having a displacement perpendicular to the direction of force. Each moment the force is acting inwards. The displacement, when you leave it, the body will move tangentially. So displacement is along the circle, along the tangent to the circle, so it always makes 90 degrees. So again the same logic, force is there and displacement is also there, but the angle which it makes is cos 90. The work done in that case is also 0. So I have discussed three cases. A person pushing a wall, in that case work done is 0 because no displacement is happening. A person carrying a bag on his head and walking horizontally, because the force which he is applying is upwards, displacement is happening in the forward direction. Again 90 degree, cos 90 is 0, work done is 0. And the third case, the centripetal force is acting inwards, the displacement is happening perpendicular to it, again the work done is 0. So these are all examples for 0 work. Now you can categorize the work into three: the 0 work, the positive work and the negative work. So 0 work example we have discussed. Now let us see positive work. Positive work means when force and displacement are in the same direction, we will say the work done is positive. For example, I am pushing a box along the horizontal, force is acting in that particular direction, displacement is also in the same direction, so that's an example for positive work. Work done by a person to lift a bag from the ground is considered to be an example for positive work. Why? Because he is applying force upwards, the body is having a displacement upwards, so that case work done is positive. Now a freely falling body, because of its own weight it is falling. What is actually weight? The force exerted by the earth over the body. So work done by the gravity in that case is taken as positive, because gravitational force is acting downwards, the body is coming downwards, so that is also considered as an example for positive work. Now example for negative work. See, assume you are pushing a body along an horizontal, so obviously the body is being moved along the horizontal by the application of a force, and between the body and the ground there will be a frictional force which is acting. and as per the frictional force is acting in this direction and displacement is happening at a 180-degree difference to it in just the opposite direction. So work done by the frictional force is considered to be negative work, because the angle which it makes is 180, and cos 180 will be equal to, in that case, force into displacement into cos 180 degree, because the angle between the force and the displacement is 180. So cos 180 is minus 1, so work done will be equal to minus F into S. So I have discussed three cases: for zero work, when there is no displacement, or when the angle between the force and the displacement is 90; positive work, when force and displacement occur in the same direction; and negative work, when force and displacement are perpendicular, just opposite to each other, not perpendicular, just opposite to each other. Hope you understood how we are writing this S into F cos theta and F into S cos theta, because normally people get confused. Isn't it the same thing? Yes, obviously the magnitude is the same thing, but the logic which is being applied to derive this formula is different. In this particular case, we are taking the component of force in the direction of displacement. In this case, we are taking the component of displacement in the direction of force. Thank you.